Right. We're going to be doing Trig, lecture 1111 and 1112 today. It is the law of cosines. The objective is the student will use the law of cosines to find the missing sides or angles in a given triangle. The way I use the law of cosines is I look at a problem and I always, if I'm asked to find a given angle or a given length of a side, the first thing I always try is to use the law of sines. And if I realize that there isn't enough information to use the law of sines, then I jump over to the law of cosines. And between the law of sines and the law of cosines, if it's solvable, you can solve the triangle. So what I do is try the law of sines. If I don't have enough information, jump to the law of cosines. That's my own personal approach on how to determine, do I use the law of sines or do I use the law of cosines? If the law of sines doesn't work, jump to the law of cosines. And here's what the law of cosines looks like. If you're given any triangle, label the sides or the angles A, B, and C, and the opposite sides will have the same letter, lowercase. Here are relationships that exist. A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of A. This relationship is true, and these two are the exact same relationship, except it's from a different perspective. Here A squared is isolated, here B squared is isolated. B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of B. And lastly, C squared is equal to A squared plus B squared minus 2AB cosine C. These relationships exist, and what we can do is find a situation where we know all of them except one, any one of them. If I know all of them except one, then I can use a little bit of algebra and solve, which is what we're going to do. So here we go. Here is the law of cosines. This is the one I have memorized, and from these it's really easy. From this one it's easy to derive those two in your head once you've done it a few times. So here we go. Use the law of cosines to find the indicated side or angle and round to the nearest tenth. In this case, we're asked to find the length of side AC. This AC is a line segment. It doesn't have a symbol above it, so from geometry that tells us we say that the length of segment AC. If I look at this drawing and the length of segment AC, I'm going to call B. And now I'm looking for B, so I'm going to use the law of cosines, which is B squared, since I'm looking for B, is equal to A squared plus C squared minus 2 AC cosine B. Okay, and that's this one right here. And I chose that one because I looked at this and I said, well, I've got C and A, I've got the angle B, I've got all of these, I know all of these, so this is the one I'm going to use. So here we go. B squared is equal to, I'm going to scoot this back a little bit because it's going to take up a little more room. A squared plus B squared, that's 400. I'm going to just go ahead and call it 20 squared, minus 2 times A times C, they're not squared in this case, times the cosine of B, whatever that happens to be, and B is 95 degrees, cosine 95 degrees. Okay. If I can get all of this into my calculator, and I can, it's pretty easy, straightforward, 22 squared plus 20 squared minus 2 times 22 times 20 times cosine 95, enter, it will give me B squared. I don't want B squared, I'm looking for B. But I'll know B squared, and to find B, all I got to do is take the square root of it. Okay? So I'm going to go ahead and find B squared, just to show you what my calculator would tell me. And let's see, we've got 22 squared plus 20 squared minus 2 times 22 times 20 cosine 95 equals. I get 960 69705 36, and this thing goes, it leaves my little window there, but it goes on forever. This is approximately b squared. Well, it's exactly, it goes on forever. I want b squared and I want to round it, so I'm going to take the square root of both sides. Take the square root of this, I get b. And here I would get plus or minus whatever the square root of this is, but since we're talking about a length, we're going to ignore the negative root because there's no such thing as negative length. So I'm going to take the square root of 960 blah blah blah, and I get 30.995 blah blah blah. It goes on forever. The reason I'm showing this is because I want to round it to the nearest tenth. That's this right here, and so I look to the digit to the right. It's a 5 or greater. It's a 9. So I'm going to round this up. It'll become a 10, and I'll carry the 1. So this will be 31.0 approximately, if I haven't made any mistakes. And if I were in a room full of you, I would say, please, if you see me make a mistake, let me know. Since I'm here all by myself, I'm just hoping I don't make mistakes. Rounded to the nearest tenth will be 31.0. Let's see if we have a unit of measure. We do, centimeters. So centimeters. And there we go. We used the law of cosines. We just plugged in the stuff we knew and solved for what we didn't know. And in this case, it was almost already solved. All I had to do was take the square root of both sides. And I've got the answer key around here somewhere. I'm going to check to see if that's correct. Yay! So 1 down. I haven't made any mistakes. Go me. Let's take a look at this one. Find the measure of angle A. Okay. Well, I've got A, B, C. I'm looking for angle A, so I'm going to use this. A squared is equal to B squared plus C squared minus 2BC cosine A. Because I know everything except for A. That's what I'm looking for. I know A, little a, side B, side C. I know all this stuff. This is the only thing I don't know, the angle A. So I'm going to plug in all the stuff that I do know, try not to make any mistakes, and here we go. A squared is 9.3 squared is equal to B squared, which is 12.4 squared, plus C squared, which is 14 squared, minus 2 times B, which is 12.4, times C, which is 14, times the cosine of A. Okay. I'm going to tell you how I'm going to solve it. Some people, what they like to do is solve this algebraically without plugging in anything into place. Subtract B squared, subtract C squared, and then divide by negative 2BC, and then plug everything in. You can do that, and then you'll have cosine A is equal to that, and then take the inverse cosine, or you can do what I'm going to do. Plug it into this, and then solve it for A. I know everything up here except the cosine of A, and I can isolate this very easily. The rest of it is just trying not to make a mistake with your calculator. And here we go. Hopefully I haven't messed up just plugging stuff in. Let me check real quick. A squared, B squared, C squared, 2BC cosine A. I don't think I've made any mistakes. Here we go. My plan is to subtract 12.4 squared from both sides, subtract 14 squared from both sides. That will get rid of these two. They're both added to this. And then I'm going to divide by this big chunk. This whole chunk here is being multiplied by the cosine of A. So I'm going to undo what's added or subtracted first, rewrite, undo what's multiplied or divided, and that will isolate cosine A. So here we go. On this side, it's going to wind up with, I'm subtracting 12.4 squared from both sides. I'm subtracting 14 from both sides, 14 squared. So now on this side of the equation, these two are both gone. And they showed up on this side of the equation, subtracted. And then I'm going to divide both sides by negative 2 times 12.4 times 14. That will isolate cosine A. So I'm going to divide by negative 2 times 12.4 times 14. And this will equal the cosine of A, cosine A. I say cosine because I'm lazy. Cosine A. And I don't think I've made any mistakes. Let me check my work real quick. Subtracted this over. I subtracted this from both sides. I divided both sides by this whole big chunk, that isolated cosine A. So yeah, what I'm going to do now, I'm going to say, well, if this is the cosine of A, I want the measure of angle A. So if this is the cosine, then A is the inverse cosine. I'm going to take the inverse cosine of this, and that will give me A. And I'll take the inverse cosine of this big mess here, and that will give me A. So here we go. The inverse cosine of this horrible looking mess, but it's just, your calculator can handle this. The idea is to not make any mistakes while I'm recopying it and talking. It's weird to say one thing and to write something else. It's a perfect way to make a mistake, which is exactly what I'm doing. So maybe I should be quiet. I'm going to take the inverse cosine of this mess, and that will give me A. I've taken the inverse cosine of both sides. When I took the inverse cosine of this, I got A. I take the inverse cosine of this, and whatever happens, if I haven't made a mistake, will give me the measure of angle A, which I will round to the nearest tenth because that's what my last set of instructions said to do. So here we go. This is exactly the measure of angle A, and we're going to round it and hopefully get it correct. Let's see what I'm shooting for here. Ooh, look at the mistake I made. Before I even get started, this 99.3 squared, I dropped that squared. That would have made a mess. Yay, I'm glad I caught that. It's because A squared equals, and I said it, but I didn't write it here or here. That could have been messy. I would have been crying and looking for my mistake and saying, whang. Here we go. For the moment of truth. 40.688 approximately, and I'm going to round that to 40.7. That's the measure of angle A, so it's going to be degrees. Let's scooch that down a little bit. So, there we go. And I think that was, yay! So I got it all in the calculator correctly. Getting it in the calculator is just a matter of, not to find the inverse cosine button, you hit shift, or on your calculator, the ones that you checked out from the school, the TI-30XS's, it'll say second function, and then you hit cosine, and it'll give you the inverse cosine. We did inverse cosine and all that stuff a couple weeks back. So there we go, now we're using it. Let's see if I have one more. I do. It's just a triangle that's given to me without a figure, so I'm going to use the same technique I used in other problems when I'm not given a figure. I'm just going to draw one. I'm not going to pay any attention to scale because my drawing is just, for my purposes, it's just a tool that I'm using to find, in this case, C. So I'm going to draw a nice little triangle. Doesn't have to be the scale because the instructions didn't say draw, a representation. It just said find C. So I'm going to use a tool. I'm going to label it ABC. Doesn't matter which one I call it, A, B, or C. What matters is, now that I've got it labeled, if this is B, then it tells me B is 15 inches, so this has got to be 15 inches. A is 13 inches, so this has got to be 13 inches. And it tells me that the measure of angle C is 60 degrees. That means C, side C is right here. If this is C, there's side C. and I want to find C. Well, I've got everything I need to use this. Here I have A, I have B, I have angle C, so I'm going to go C squared is equal to A squared plus B squared minus 2AB cosine C. And if you're wondering where in the world that's coming from, this is the one I just used because I saw, hey, I know these three. I know everything. So that's what I'm going to use. Makes life a little easier. So here we go. C squared is unknown. That's what I'm looking for is C. So C squared is equal to A squared, which is 13 squared, plus B, that's 169. B squared is 15 squared, which is 225, minus 2 times 13 times 15, 2AB, times the cosine of whatever that is, 60 degrees. And hopefully I won't mess this up. Last time I left off a square, that would have messed up the whole problem. So let's see if I've messed up anything here. C squared is equal to A squared plus B squared minus 2 times A times B cosine C. So I think that's correct. We're going to plug all this in to the calculator and hit enter or equals, and that will give us C squared. I don't want C squared, but one thing at a time. So we'll go 13 squared, that's 169. Cos 60 equals, I get 199. C squared is equal to 199. I don't want C squared. I want C, so I'm going to take the square root of both sides. So this would be C equals plus or minus the square root of 199, but I'm going to ignore the negative root because we're talking about length. And there's no such thing as negative length, so I'm just going to use the positive root of this quadratic equation. So I'm going to say square root of 199, which is about 14.1 units. C is approximately 14.1 units. That's a weird looking 14. And our units are inches. So there we are. We're going to use one of these three. And you can do it by just trial and error. If you look and you say, well, I don't know which one to use, we'll try one. And if it's not the right one, try another. There's only three of them. Right? Try one that will just leave you with one unknown and solve them. Don't forget, if you're looking for an angle, your unknown's going to be over here, and you're going to have to do a little bit of algebra, then take the inverse cosine of both sides. You can do this. It takes a little bit of practice, but you can do it.